area of a triangle whose vertices, the coordinates of the vertices are given as x1, y1, x2, y2 and say x3, y3. You have already done in coordinate geometry in your class 11 that area of triangle is half the modulus x1, y2 minus y3 plus x2, y3 minus y1 and plus x3, y1 minus y2. This already you have done. And you know area finally we take positive. Now this expression for area of triangle may be rewritten in determinant form as half outside determinant. You write the coordinates of the first point in the first row x1, y1, 1 to make it a determinant of 3 by 3 order. In the second row you write x2, y2, 1 and in the third row you write x3, y3, 1. Just check, is it the same value of determinant? See, you expand it with respect to first column. So you get x1 times, delete the row and column through x1, you get y2 minus y3. Then minus x2 times, delete the row and column, you get y1 minus y3, but you adjust the minus sign inside, you will get y3 minus y1 and similarly the third term. So now here in class 12, if you are asked to find the area of a triangle, vertices are given, instead of using this formula which you have done in class 11, directly will make use it in the determinant. So if I denote it by symbol determinant, you know, finally the area of triangle we always take positive, so take modulus of it. Remember, the sign of determinant is not exactly the sign of modulus. The value of determinant of a squared matrix may be positive or negative, but then for area of triangle we'll take modulus in case it comes out to be negative. So that is one point you should note. Now another point to be noted here, that if 3 points ABC are collinear, if ABC are collinear, if 3 points lie in a line, there is no more triangle here. So if at all you apply area of triangle formula, what should come out to be? 0. So both ways, 3 points ABC are collinear if and only if area of triangle is 0, or in other words the value of determinant, or in other words the 3 points ABC are collinear if and only if half we can omit, because half multiplied both sides by 0 will not make a difference. So it is x1, y1, 1, x2, y2, 1, x3, y3, 1. If the value of this determinant is 0, then the 3 points are collinear, and if the points are collinear, then value of this determinant should be 0. So that is about area of triangle. Now next let me come to the exercise questions. Question 1. Find the area of triangle with vertices at the points given in the following. In the first part, the coordinates of the points are given as 1, 0, 6, 0, 4, 3. So what will be the area of triangle? Half. First let me write the formula. x1, y1, 1, x2, y2, 1, x3, y3, 1. And now replace the value of x1, y1, x2, y2, x3, y3. You have half the times the value of determinant 1, 0, 1. The coordinates of the second point are 6, 0, so 6, 0, 1. That of the third are 4, 3, so 4, 3, 1. And now you just evaluate it, say along, let me expand the determinant along row 1. You know, in general we can do it with row 1. Half is still out and you expand it, you get 1 times 0 minus 3, and minus 0 time will simply be 0, and plus the third element 1 time, delete the row and column through 1, you get 6 3s are 18 minus 0. So you get half outside, you get minus 3 and plus 18, that is 15 by 2, and you should write, because it is area of triangle, 15 by 2 squared units. That you should write. Now take the second part. The coordinates of 2, 7, 1, 1 and 10, 8, you already know the formula. You have written in the previous part that it is half the value of determinant x1, y1, 1, x2, y2, 1, x3, y3, 1. So substitute the coordinates, you get half the determinant. What are the coordinates of first point? 2, 7. So the elements of the first row will be 2, 7, 1. That of the second row are 1, 1, 1. In the third row are 10, 10, 8, 1. So evaluate the determinant. You may directly evaluate it, or if you like, you may simplify to get 2 zeros. It's all up to you. So because you have 1, 1, 1 in the third column, so let's apply the properties of determinant. Because once you get 2 zeros, it will be easy to evaluate it. Okay, let's try that. Replace R2 by R2 minus R1 and R3 by R3 minus R1, keeping R1 the same. So half R1 the same, 2, 7, 1, and R2 minus R1 gives you 1 minus 2 minus 1, minus 6, 0. Similarly in the third row, after operating R3 minus R1, you get 8, 1, 0. And now you should expand it along which row or column? Obviously along third column. So expand along C3. So you get 1 time half outside. You know the sign convention, plus minus plus. So it will be 1 time, delete the row and column through 1, and you get minus 1 minus 48. So it will be plus 48 there. So you get half the time, you know, minus 1 plus 48, that is 47 by 2. So you get 47 by 2 squared units is the required area. Now the next part, the last part of question 1, the area of triangle. You are expected to first write the formula x1, y1, 1, x2, y2, 1, x3, y3, 1, where you know x1, y1, x2, y2, x3, y3 are the coordinates of the point. And now substitute the coordinates. The coordinates of the first point are negative 2, negative 3, 1. So you get 3, 2, 1, the elements of second row. And third row you should write negative 1, negative 8, 1. In this case also, if you want to simplify, so apply R2 minus R1, R3 minus R1. But if you find it is, more complicated, you can directly evaluate it with respect to any one row or column. It is not a compulsion on you that you first simplify and then do it. So replacing R2 by R2 minus R1 and R3 by R3 minus R1, what do you get? Half is yet out. Determinant, the first row minus 2, minus 3, 1 as such. By taking R2 minus R1, 3 minus 2 will make it 5. Similarly 5, 0, and you get 1. And minus 8 minus plus 3 will make it minus 5 and 0. And now obviously you evaluate it. So expand with C3. So half is out and you get 1 time minus 25 and minus 5, and of course the other two elements will be 0, 0. So you get half into minus 30 minus 15. But we never give the area in negative. So finally you should write the area of triangle is modulus of negative 15, that is 15 squared unit. So take the modulus of it. Question 2. Show that the points A, B plus C, B, C plus A, C, A plus B are collinear. 3 points are collinear 3 points, say x1, y1, x2, y2 and x3, y3 are collinear if the value of determinant x1, y1, 1, x2, y2, 1, x3, y3, 1 equal to 0. That is the condition. Because actually, you know, this is the area of triangle with half the time, but half we can cancel, this being equal to 0. So the condition reduces to x1, y1, 1, x2, y2, 1, x3, y3, 1. Value of this determinant should be 0. Substituting the values of the 3 points x1, y1, x2, y2, x3, y3. So take left hand side expression and let's see if we can prove it equal to 0. So what are the points? You have the coordinates of the first point a, b plus c, write a, b plus c 1, b, c plus a 1 and c, a plus b 1. We want to prove that value of this determinant is 0. You know, you may expand, but it will be very easy if you apply the properties of determinant. If any two rows or columns of a determinant are identical, you know it will be 0. So instead of expanding, we can directly prove it using properties. So the first thing is that you apply C1, change C1 by C1 plus C to Y, because then all the elements of C1 will become A plus B plus C, which after taking common, you will get 1, 1, 1 in column 1 as well as in column 3, and the two columns being identical will get it 0. You know, before you apply the properties of determinant, you have to think it orally, the advanced steps, why we are doing so possibly. So you get in the first column A plus B plus C, B plus C plus A, C plus A plus B. As a matter of fact, A plus B plus C, all the three cases. So the second column B plus C, C plus A plus B. Third column you get 1, 1, 1. And now taking A plus B plus C common from column 1. The value of determinant is 1, 1, 1 and B plus C, C plus A plus B, 1, 1, 1. And now you may say that the value here only you may say the value of determinant is 0. Why? As column 1 equal to column 3. The two columns are identical. And here we can conclude as the value of determinant is 0, so the 3 points A, B, C are collinear. So that's it.